Assalamualaikum and hello. My name is Muhammad Shafiq bin Muhammad Yusuf. I'm from UiT MKT. In this video, I will be showing you my final year project system, which is supplier selection using the fuzzy TOPSIS algorithm. Okay, first thing first is to rank the criteria. Here we can rank the according criteria, which is price, quality, delivery, performance, history, according to which we desire. There are 5 listed, which is little important to absolutely important. So in this case, I will be ranking the criteria according to the average contractor chose. Next is to rank the supplier. We rank accordingly with the supplier and the criteria such as the price of the supplier one, the quality of the supplier one, delivery of supplier one, and the performance history of the supplier one. I will rank them randomly by assuming what supplier 1, supplier 2, and supplier 3 is. As a contractor, they should know what supplier they want to compare with. Okay, next, this is all empty. If we click calibrate, the algorithm will calculate the linguistic term, which is this term, very low to excellent, into fuzzy number, and then calculate to produce an output, which is the closeness coefficient. Okay, first thing first is to convert the linguistic term to fuzzy decision matrix. As for the high, it will be 5, 7, and 9. The good term will be 3, 5, 7. The low will be 1, 3, and 5. And the excellent will be 7, 9, 9. So next is the normalized fuzzy decision matrix. To get this value is by the algorithm, the fuzzy TOPSIS algorithm will compare column by column, which is row by row, which is supplier 1, supplier 2, and supplier 3 by column. So it will compare the first column and the first row with the second row with the first column and the third row of the first column. So in this case, the highest it will take the highest and divided all of the value with the highest value. The formula is shown here. As for example, in this case, the highest is 7, the third row and the first column, which is 7, 9, 9. So all this value will be divided by 7, 9, and 9. Here's the result. Next is the weighted normalized fuzzy decision matrix. To get this value is by multiplying the weight of the criteria and the value of the fuzzy decision matrix. So the weight of the criteria, like here, is very important, which is 5, 7, 9. So it will multiply with this value. So it will get 2.78, 5.44, and 9. And the rest is pretty similar. And then next is to get the fuzzy positive ideal solution and fuzzy negative ideal solution, or in short form FPIS or FNIS. To get this value, the fuzzy TOPSIS algorithm will compare like before, but if there is a case which the third value has the same number, in this case, like the second row and the third column, and the third row where the value is 9, so the algorithm will switch to the middle part. where it will compare the second value of the second row and the third row, where the 5.44 and the 7. So the 7 has the highest. So the FPIS will be 3.89, 7 and 9. Whereas the FNIS, the fuzzy negative ideal solution, it will be comparing from the left to the right, where FAIS before will be compare right to the left. Where in this case, there will be some cases where the first number has the same value, but the middle will be compared, like as this one 2.78 and 2.78, but the middle is the same, so it doesn't matter, it will take this value. And then next is the distance from each alternative to the FPRS D+. The formula is here. And lastly is the result page. To get the closeness coefficient, so the D minus will be divided by D minus plus D plus or D star. It is much pretty the same. The symbol is the same. So D minus divided by D minus plus D plus. So it will get 0.37. In this test case, the highest closeness coefficient is supplier 3, which is 0.6. So the optimal solution for decision maker or the contractor is to choose the supplier 3. That's all. Thank you.